Okay, so today we have to deal with this June bug here, and this motherboard has a rather interesting problem. I've never seen this kind of symptom before on an Amiga. So what's happening here is that when I turn on the power, it starts to perform the self-tests and everything, so far so good. But just when it's about to reach the kickstart screen, the screen just goes black and the system dies. So let me hook the motherboard up and show you what's going on here. Alright, so here I have it hooked up through composite video to my video capture card, and it's just showing a blue screen now because it's not detecting any signal. So let me turn on the power here and we'll see what happens. Self-test, and there it just dies. Okay, let me show you that one more time. And I will wait for a few seconds before turning it back on. I think that should be enough. Okay, here we go. Self-test, and bam. And that's pretty much it. That's what happens. And in case you're wondering, yep, I have already tested this ROM on another motherboard and it's confirmed to be working. And by the way, if anyone is interested, the version here is 2.05. Now of course, since it is starting to perform the self-tests on power up, it's not very likely there's something wrong with the system clocks, but let's check that just for the sake of it. So we have the system clocks coming out from Agnes here on these pins here, around this area. But it's easier to just probe these resistors here. So let's start with this one here. And there we have a clock, and let's check the next one here. And there we have a clock signal, next one here. And clock, next one. Clock, next one, clock, and next one, clock, next one, clock signal, and the last one, and there we have a clock signal. So yeah, nothing wrong with the clock signals there. I just discovered something here, so let me show you this. Here I'm probing the three sync signals at the video connector. We have vertical sync here, horizontal sync here, and the composite sync signal is here. So let's take a look at the scope and see what happens when we turn on the power. Okay, so here we got composite sync, horizontal sync, and vertical sync. So let me turn on the power here and we'll see what happens. 3, 2, 1. And there it just dies. And okay, let me turn off the power here. And let me show you that one more time. Let's turn on the power. 3, 2, 1. And there we have the sync signals, and they just disappear. Power off. Now of course, during a repair like this, it's always a good idea to inspect the motherboard at an early stage. So that's what I have done just now. And here on the upper side of the motherboard, it doesn't seem to be anything here that could affect the motherboard and make it malfunction. Here I found something, but it doesn't seem like this is close to any traces or vias or anything. And this here, this doesn't seem to be affecting much of anything. So here on the upper side everything seems to be alright, but let's flip the board over and have a look at this side. Okay, now I found a few things here. So first of all, here I found this. Let me see if I can get a good angle in there. Here. Now this could be a problem. I don't really know if all the vias are still intact there. I will have to check that with the meter. And I also found a few things in this area that could be a problem. Here, let me show you. Let's see if I can get a good angle there. Okay, I think you can see that. So that doesn't look too good, I think. And I mean, take a look at this. It's kind of heavily corroded there, those two vias, and here also. So this could be a problem, really. I would like to check something here. These two vias, they are quite corroded, as you can see. And this via here, it's going off here. And it's connected to this via here, which is also a bit corroded. So I would like to check to start with if those two vias have a connection with each other on the upper side of the board, because these two wires, this one and this one, they are not connected to anything else here on the bottom side. They're just hooked up to each other. So it's easy to see if this is a problem by checking for continuity on the upper side of the board. Okay, so let's see, it's this wire here, there, and this wire, let's see, here. Not a problem. Now the trace for this other wire here, that's a little bit more difficult to track because it's quite long, but I did manage to track it like this to this point here. So that means that this wire on the other side of the board should have a connection to this point, and this point here on the other side of the board, I figured out that that is this point here, right here, and that is going to Gale. So this point here, right there, that point should have a connection with the corresponding wire here, and let's see which wire that is. Okay, so it's this wire right here, so let's check for continuity. And there, and here. Nope, no continuity. So that could be a problem. Let's do a little experiment here. Here I have a piece of wire. Now I wonder what happens if I take this piece of wire and I put it into the hole here of this wire, right there, like that, and then I take the other end of the wire and I hold it against this point right here, and while doing so I turn on the power. Then what happens? Well, let's try it out and see. Alright, the motherboard is hooked up again, and here is the wire sitting in that wire there. And let's take the other piece of this wire and hold it against that wire there, right there. Let's see if I can do this. Okay, there. Now let's turn on the power here. Well, it's still a white screen there. It would have gone black already by now if it wasn't working. Let's see here. Come on, you can do it. Come on. Ta-da! Okay, it wasn't really that difficult. There we got it. Problem solved. Now maybe you're wondering what signal is going through that trace, so let me show you here. Okay, to start with, like I mentioned earlier, this point here is going to this pin here of Gale at position U5, and this wire here, right here, it's going off up to this chip here, the odd CIA at position U7, and the pin it's going to is this one right here, the fourth pin from the right. There we have it, right there. And here we have it, Gale at position U5, pin 73, it's the odd CIA signal. And here we have the odd CIA chip at position U7. And here at pin 25 we have the odd CIA signal. Now, how a break in that trace can cause this kind of problem, I don't want to speculate around that too much, but if you have any information on that, maybe you can let us know in the comment section. here's that wire that has a break in it, so I will have to do something about that. And here we have the other wire that also is quite corroded, and it's connected to this wire here, but these two wires do have continuity. We checked that earlier, but still I will have to clean up here and try to get rid of this corrosion and make sure that the wires are connected to the traces in a reliable way. And I will have to check for some other areas here that are a bit corroded and try to fix that as well. Here, for example, this doesn't look that good. Oh, okay. I'm not sure if these traces are connected to the wires there, or if, well, they kind of look, it looks like they are connected, but I don't know if the wires, yeah, if they have a connection to the other side of the board. I'm not sure. But this is just for this expansion connector, but still it would be nice if the expansion connector works, so I will see what I can do here. Now this doesn't look that good either, so I will have to see what I can do about this. There seems to be quite a lot of corrosion on some of the wires there, so they might have suffered a bit of damage, but of course it's hard to tell without cleaning up first in this area. Now this is how wires and traces should look like. No problem here. But up here it's a bit worse. Okay, so now I will have to see what I can do about this corrosion. But I'm not going to film everything because it's probably not that interesting for you guys to watch when I'm soldering and cleaning and doing all sorts of stuff like that. And besides, it might take a little bit of time, so I'm going to do this off camera and get back to you later. Alright, so I'm back again after doing some cleaning, and I'll tell you what, let's take a look at the before footage and after footage side by side so we can do a little bit of comparison here. Alright, now take a look at the via on the right image. See that pad there on top of that via? That pad and the trace. Now that, my friends, is why this Amiga is not working. And this is not something we could see before removing the corrosion. Even with a microscope it was not possible to see that, as you can see here. So sometimes you just need to clean up before going over the board with a microscope or something. Now this wire still has continuity, we already know that, but look at it, it's almost completely destroyed. There's not much of any copper left there around the pad of that wire. So this is not something we would like to just leave like that, because it's really unreliable, and just a little bit more corrosion on the top of that wire there and bam, connection is gone. So this is something I will have to fix as well and create a little bit more reliable connection there. So okay, let's move on here. And here, take a look at this. Only around half the width of that trace is still connected to the wire. So if I don't do anything about this wire and the other wire that this trace is hooked up to, this connection and this signal is probably the next one to go. So I should really do something about this. I'm back again sometime later with a small correction. It looks like the via and the trace are not that well connected there, especially here. At this point it looks like the copper has been eaten away, but as it turns out that is not actually the case. After doing some more cleaning it looks like this, and here we can see that the via and the trace actually are connected in a reliable way. So well, there you go. Okay, moving on here. I have to say that I'm a bit surprised, because the vias we see here, even though they were quite corroded, they still seem to be intact to such a degree that I probably don't have to do anything more about them. And that's good. I expected things to look a lot worse here. But we have at least 3 vias so far that need a little bit more attention. By the way, if you're into this kind of do-it-yourself electronic repairs, I can really recommend you to get a USB microscope if you don't already have one. They're quite cheap, and they can be really useful sometimes, as you can see here. Alright, now as far as I can see it, I have 2 options here. I can either put a jumper wire between this via and restore the connection that way, or I could do a more discreet and proper fix and repair this via, and then I don't have to put a jumper wire between these 2 points. So, which option should I go for here? This is a really tough decision. So we now know that there was a break in the trace that is carrying this odd CA signal, and that is what caused the failure to happen. And now the connection is restored and the Amiga is working fine once again. But I'm kind of wondering here, why did we get this kind of symptom? Why did the Amiga perform the self-tests to a certain point and then we got a black screen? Why didn't we get a black screen instantly when turning on the power? Or why didn't we instantly get a green screen of death or something like that? So, okay, let's take a look at this. Here we have the odd CIA signal, and it's going into pin 25 of the CIA chip, and that pin is labeled CS. So then we can take a look at the datasheet here, and this is the datasheet for the 6526 CIA, and on the Amiga we have the 8520, but it really doesn't matter. The 6526 is just the older version, so it really doesn't matter. So let's scroll down here, and we're getting to this block diagram, but let's continue here. Usually in datasheets like this one, there's usually a description of the signals. Yeah, here we have it. So CS, chip select input. So it's just a chip select signal. That's all there is to it, you know. And apparently, according to this, all that signal is doing is selecting the chip and making it listen to the other signals. So if we then go back here, so okay, then again, when this signal is low, then the CIA chip will respond to other incoming signals, like for example signals coming in here on these RS pins here. And well, that's it basically. But I really wasn't happy with that. I wasn't satisfied, so I wanted to know more. So what I did was to hook up my logic analyzer to this CIA, and ba-bam, here we have it. So here is my capture. I captured this from the Amiga when it was working, so this is after the repair, and here we can see that I turned on the power right here. We have these rising edges here on all these signals, so that's the point where I turned on the power, and I can just put this marker here, and then here you can see also the time here. So as time started to pass by, different things started to happen, and here we have this odd CIA signal up here. So if we take a look here, we can see that there's something happening here. So let's zoom in here. Okay, so we got 3 narrow pulses there, and that is the first pulse is starting at 1.177 seconds or so after I turned on the power. But when the Amiga was not working and it went to a black screen, it did that after like 3 seconds or so. You can rewind the video and have a look at that if you want to, but I timed it to around 3 seconds. So let's take a look here what happens after 3 seconds or so. So okay, here we have the time here, so we have 3 seconds around here, right? Here is 2.8 seconds or so. So it all adds up, because here this odd CIA signal, it's starting to become more active here. So this chip, the odd CIA chip, is being selected here. We have all these pulses going here. You can zoom in here, you know, lots of pulses here, and here also we have a burst with a lot of pulses, kind of short duration there, 875 nanoseconds or so per pulse, and yeah. Anyway, so that's what's going on. It's nothing, not much more to it than that, really. Just that this signal, it was not active. The Amiga started to perform the self-test, and this odd CIA signal, it was high most of the time. I don't really know why it passed this point here. It's kind of weird. But it did that anyway. So okay, so it managed to pass this point here, right here, and then it moved on here, and then bam, right here. You know, it couldn't select the odd CIA chip because this signal was cut off. So then the system just crashed, and that's basically what happened. Nothing more to it than that. So yeah, that's it, I guess. Okay, so now when the motherboard is booting up again, I noticed that the audio coming out from the left channel here is slightly lower than the audio coming out from the right channel. Here, let me show you. So here I have ProTrack running, and this is the left channel, and this is the right one. So, okay, here we go. And maybe it becomes even more obvious if you take a look at it on the scope. Here I'm probing the outputs. They are going directly to my scope probes, just like that. And the scope is set to 100 millivolts per division. And here's the left channel, and I will now switch to the right one. So there's the right one, and there is a clear difference there in amplitude. So right, left, right, left, and both. And I suspect that this has to do with this AC coupling capacitor right here. But I'm not completely sure about that, so how can I verify it? I would rather not have to take the whole capacitor out of there just to check it, especially since it's in such a tight location. So how can I check whether or not this capacitor is causing this problem without having to desolder it from the board? Well, I guess some of you guys are thinking about an ESR meter right now. And yeah, true. An ESR meter can be quite a useful tool at times like this, but unfortunately I don't have an ESR meter. So I want to check whether or not this capacitor is causing this problem without having to desolder it from the motherboard. And I don't have an ESR meter. Oh my, what am I going to do now? Well, as it just happens to be, using an ESR mirror is not the only way to check whether or not a certain capacitor is causing a problem in a circuit. Well, depending on the application, of course, but in this case we're just dealing with an AC coupling capacitor, and we have the audio output right here. Okay, now what if I do like this? Okay, now let's assume that this capacitor has gone bad and has a really high ESR. So then what will happen? Well, we're bypassing this capacitor with this capacitor here. So we know that this capacitor is a new and fresh capacitor with a low ESR, and if we assume that this capacitor has a high ESR, we will just bypass this capacitor and the current will take this path, just like this. And the audio will then go back to its normal amplitude. So it's basically the same thing as bypassing a certain resistor with just a wire like that, but we're bypassing this the ESR of this capacitor with a new capacitor that has a low ESR. So let's do that. Let's bypass this capacitor and see if the audio goes back to the normal amplitude. So here I have a 100 microfarads capacitor. The value doesn't really matter that much, but I guess it should be at least 22 microfarads because that's what we got in there. So okay, let's try this out and see if we can bypass this capacitor that's in there. Okay, so clearly there was a difference there. Now how about the other channel? Let's see if I can get in there. Nope, no difference. And let me just show you this on the scope as well. So of course the signal there with the low amplitude is the one coming out from the left channel, and the signal with the high amplitude is the one coming out from the right channel. And now I'm again going to bypass that AC coupling capacitor on the motherboard with my other capacitor here, and we'll see what happens. So here we go. There we go, and not much to our surprise, the amplitude of that signal is now back to what it should be. So I think it's pretty obvious by now that this capacitor has to be replaced, and if I'm going to replace this one, I might just as well replace this one too, because I want to make absolutely sure that both these two capacitors have the same ESR and stuff, so the audio will not be different between both channels. So I'm just going to replace both these two caps, and then I will be done working on this motherboard. Alright, so I got the new capacitors in there. I was actually out of 22 microfarad 6.3mm surface mount capacitors, so I had to order some of them, but now when they have arrived I could finally put two new ones in there. And I managed to get a decent amount of solder in there, just the right amount, and good wearing and no damage to the keyboard connector whatsoever, so I can be quite happy with that. Now I just need to put the RCA jacks back in there, and then after that I'm gonna be done working on this board. Alright, perfect. Okay, cool, so I'm gonna hook up the motherboard once again, and with the help of my little assistant here, I'm gonna check if the audio coming out from the left channel and right channel both have the same amplitude. Hopefully things will look a little bit better than before. What? No audio on the left channel? Oh, come on. What's wrong now? gotta be kidding me, man. Oh, alright. Well, can't be that difficult to track this down. Are the speakers really working properly? Let's see here. Right one. Yeah, but we got audio from that one. How about the left one? Yeah, they're working. I can even change the position here. Change places like that. And let's see. Yeah, same thing. Alright, let's see here. It's quite difficult to get in there with my scope probe, so I'm just using a needle like this. It makes things a bit easier. Let's see, do we have audio on this side? Let's see. Yep, apparently we do. And on the other side here. Yep, the capacitor is working fine. I can check that one just for the sake of it, but that channel was working. So it doesn't really matter, but anyway, the other side here. Yeah, got audio on all sides, so both sides of these two capacitors, so no problem there. So something between here, this side of the capacitor and the RCA jack, I guess. Let's see here, where do we have audio here? This is the working side. Now that's weird. We got audio here, and that is like expected, of course. And we have audio here as well. But now if I probe here, we also got audio there, and here, yeah, there as well. Wait a minute. I think I get it now. I think I get it. Let's see. When I plug this in, the audio from this one goes away. Left, only right, only left, only right. I get it now. Okay. So what we just saw now all has to do with the mechanical stereo mixing between these two RCA jacks. And what do I mean with that? Well, maybe you're familiar with that several Amiga models have this kind of feature, or whatever you want to call it, which makes the audio be mixed to one of the RCA jacks if only one cable is connected. What I mean with that is this. If only one cable is connected like this, then these two RCA jacks will both output mono. So there will be the same kind of audio coming out from this channel, or this jack, RCA jack, and this RCA jack. So they get mixed together inside these RCA jacks when only one is connected. And only when both are connected like this, only then will they get separated and isolated from each other. So the left audio will come out here, the right audio will come out here. And that is actually caused by a sort of mixing, a mechanical mixing inside these RCA jacks. And that is why we have three solder points here, 3 poles, one here, one here, one here. So this is obviously the ground plane here, and same thing here. And here we have two other points here. Normally you would think that one would be enough, right? But here it's not, because we have this kind of mixing, so they need 2 more poles here. And we can see a trace here joining these two together from here. This trace is going to that one, and here's a trace joining these two together. So we have this kind of cross connection going on here. And if you want to know more about how everything is interconnected on the board here, you can always check the schematics by yourself. But the point here I want to make in all of this is that what I think happened when we had only one plug hooked up like this just now, what I think happened was that the audio was leaving this capacitor, and then it reached this RCA jack. But since we didn't have anything hooked up here, we had this kind of mixing going on between these two jacks. So the audio that reached this RCA jack got coupled over to this RCA jack, and then it just left this, this RCA jack, and it went through the cable and to the speaker. And that's why we could hear audio there when we only had this connected. But when we plugged this in, then suddenly we got isolation between these two RCA jacks. So the left channel got, we had an output here from the left channel, and the right channel got out here. So we didn't have any mixing here anymore. And I think there might be a break somewhere between this capacitor and this RCA jack. And that is why we don't have any output here when both are connected. Because when both are connected, well, the audio cannot take this way to this RCA jack and then be coupled over to this RCA jack. So we don't have any audio here because there's a break here, so no audio is coming, is reaching this RCA jack from this capacitor. And also, earlier I checked these two negative points, the negative point of this capacitor and the negative point here of this capacitor. I checked that on the scope, and we had output on both capacitors. Well, that was not really very smart of me, the way I did that, because when I did that, I didn't have anything hooked up here. And when I measured here, when I probed this point here, this capacitor, the negative terminal, we can imagine that this capacitor was completely gone. What would have happened was that, well, audio was leaving this capacitor, reaching this RCA jack, getting coupled over to this RCA jack, and then getting back and fed back to this point here. So we were kind of reading the audio that was coming out from here when probing this point, when there was nothing connected here. So yeah, I should have done this basically, just this, hook up these two like that, and then check this point and this point. But, well, didn't think about that. Oh well, I guess I can do it again. But I'm almost sure that there is some kind of break between this capacitor and this RCA jack, because these two capacitors are completely new. I mean, there is not going to be anything wrong with this capacitor. It's not likely at all. There is a break between this capacitor and this RCA jack, that's for sure. And about this mechanical switching that is happening inside this RCA jack, well, I can even show you that. So here I have my 2mm probes hooked up to these two leads, and the meter is set to continuity check now. And here on the RCA jack we have the ground pin right here. So if I now take these two alligator clips and hook them up to the two other pins here, like that, and this one goes here, then we have continuity. But if I now take this, or say plug and just hook it up like that, then we don't have continuity anymore. So this stereo mixing that's going on inside the Amiga when only one RCA plug is connected, that is all happening inside the RCA jacks. And we can of course also check which pin is the real incoming pin for the left channel of these two pins here when the audio is not being mixed. So let's do that quickly. I'm going to hook up this here and let's see. Okay, so it's not this one, but this one here. Okay, that can be good to know for future reference maybe. Okay, now it just works. Electronic devices can be so unpredictable sometimes. Okay, so play, see, works. Have the left channel here, right channel here. So yeah, it works. So what did I do here in order to make it work again? Well, not much actually, because I haven't done much of anything. I haven't resoldered anything since last time when it didn't work, or yeah, I haven't done anything like that. The only thing I did basically was to probe here a little bit with my multimeter. So I put one of my probes here on this wire, and you can see this joint here for this capacitor, and there is a wire just to the left of it. So I put my multimeter probe there in order to check for continuity with some other points on the board. And that is all I did. I checked around a little bit for continuity while having the board disconnected from all cables, of course. And well, yeah, that's it. After that, it just started working again, all by itself. Really strange. But what I do think has happened here is that this capacitor was the one that went bad, as you know. So I think this capacitor, or the other one that was in there that went bad, I think it might have leaked a little bit onto this wire, which might have corroded this wire just a little bit, and I think because of that this wire might be intermittent now with the trace or something. So I think when I probed it, I restored the connection. That's the only explanation I can think of right now, because if I press play here and I will activate only the left channel there. That was the channel we had problems with. And now let me do like this. Okay, wiggle, 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 wiggle. You know, there is no intermittent connection problem on the RCA jacks. I did solder them properly. I did solder the capacitors properly. You know, it's no problem there. And it's still working. I don't know. It has to be that wire. That's the only explanation I can think of. Yep, you got it. It seems like that wire has seen better days. Oh man, I should have checked that wire more carefully when changing the capacitor, because I knew the old capacitor was bad. Oh well, lesson learned. Okay, it was kinda tight there since both RCA jacks are still on the motherboard, but I did manage to get in there and clean some of the corrosion off the wire. And I also scraped a little bit of the solder mask off the trace, and that is of course on purpose, because I want to solder on it when fixing it up like I did with other wires. Alright, so I had to remove the left RCA jack again in order to get in there with my soldering iron, but there we are. I think this is kind of interesting. It seems like the isopropyl alcohol is leaving a somewhat glossy surface on the motherboard even after it has dried up. And that is usually not visible to the naked eye, but under strong light conditions and heavy magnification it becomes really obvious, and especially at certain camera angles, because the light is really being reflected towards that glossy surface. So under some certain camera angles with my USB microscope, it seems like I haven't really cleaned properly, but that is exactly what I have done. Here, take a look at the left of this wire. It looks pretty clean, right? But when I change the angle of my USB microscope, it starts to look really different. Here, see, it seems like it's almost dirty there, but well, it's not really dirty. I have cleaned. So that is just the light being reflected to the board. Oh, it's dirty, it's dirty, oh, it's not dirty. Oh, great, it's clean there to the left of the wire. Oh no, it's so dirty. Oh, what a bad soldier. Oh, it's clean, nice. And at the bottom side of the board, this little wire is sticking up through this wire. right here. So, there we are. Okay, now that connection is certainly not going to be intermittent anymore. I can tell you that. So, let's test this once more. Like that. Only left channel playing now, this one. But you know, it's gonna work, of course. Yeah, no problem. Yeah, okay, it's working. So, what was it I was about to do earlier when I was so rudely interrupted by that intermittent wire there? Oh yeah, that's right, I was gonna check on my scope here if the audio from the left channel and right channel is equal in amplitude. So, let's do that now. Okay, left channel, right channel, and as you can see, absolutely nothing to worry about. Everything is just as it should. And if I do like this, we can get a little bit more resolution there. Yeah, okay, there is a small difference there, but the scope is not perfectly calibrated between the two channels either, and besides, there might also be a small tolerance difference in the feedback resistors for the op-amps on the Amiga motherboard, and that small difference might also create a very small difference in output volume. So, you know, this doesn't necessarily have to do with the capacitors. And I can also check the same thing on the very same channel with the very same probe on this scope. So here I have a 400 Hz sine wave coming into the scope from the left channel on the Amiga. So let's save that here, and okay, let's save it like that, okay, and then let's probe the other channel here, the right one, like that, and let's display the other one. Okay, so the live updated one here, that is the right channel, and the one we saved here, that is, you know, not being updated, that is the left one. So here, the one that I'm moving around, that is the right channel, and well, I would say that the amplitude is pretty much the same. And with this, I would like to say that this repair is now complete. If you have any comments or questions regarding this repair, you know what to do. Okay, thank you, and see you again next time.